we're talking about dividing positive and negative. And we want to think about reciprocals and opposites. With addition, we work with opposites. We always change subtraction to addition, and we work with opposites. And opposites, when we add them together, equals 0. 4 plus negative 4 would equal 0. With multiplication, we work with reciprocals. When we multiply reciprocals, they equal 1. So 3 times 1/3, those are reciprocals. They equal 1. A lot of times we think of it as two numbers that are one flipped upside down from the other. Now, since they multiply to equal positive 1, they have to have the same sign. So for negative 2, we have to multiply that by negative 1/2 to get 1. For 2/3, that's already positive, so we multiply by a positive 3/2 to get 1. For negative 4/5, we have to multiply by the same sign, so we'd have to multiply by negative 5/4 to get a positive 1. And for negative 6/5, we multiply by negative 5/6 to get 1. We rewrite all subtraction as addition using opposites. So we learned before that we rewrite negative 2 minus 7 is negative 2 plus negative 7. And we learned that as keep, change, opposite, or maybe you learned it as copy, change, opposite. Either way, you learned that you were supposed to keep the first number the same, change subtraction to addition, and then whatever sign you have on the number after subtraction becomes the opposite sign. So that positive 7 becomes negative because it's following a negative or a minus, a subtraction symbol. The same idea happens when we're dealing with division. So if I have negative 5/8 divided by negative 3/4, I'm going to keep, change, reciprocal. You can also think of it as copy, change, reciprocal, whatever way you learned it in 6th grade. So I'm going to copy down the first number, change the division to multiplication, and write the reciprocal of the second number. So that's keep, change, reciprocal, or copy, change, reciprocal. Once we do this, we have a multiplication problem, and we can just deal with it like multiplication, where we cross cancel and then multiply numerators and denominators. Another thing I wanted to mention was this idea of negative and positive fractions, to make sure everybody understands negative and positive fractions. If I have, say this problem, negative 5/8 times negative 4/3, the way I think about it is I have a negative times a negative, so that's going to equal a positive. I don't really break down where the negative is in each fraction. Okay, so, and when I'm cross-canceling, I don't worry about the negatives. To help you understand more about working with the signs of your fractions, if you have something like negative 2/3, that can be written as 2 over negative 3, or the whole thing with the negative beside it. All of those mean the same thing. That is the notation. Those three are notations that mean a negative value, that the fraction is negative, because it means negative 2 divided by positive 3, which is the negative value, or 2 divided by negative 3, which is the negative value, or the opposite of 2 divided by 3, or the whole thing is negative. So that's what each of these notations mean, in helping you understand how to read your fractions with negatives. Versus if you have 2 over 3, and both of those are negative. That means the same thing as positive 2 over positive 3, because negative 2 divided by negative 3 is going to give you a positive, just like positive 2 divided by positive 3. And you can write a positive fraction in either way, although we usually do not write it as a negative over a negative. All right, so let's talk about dividing mixed numbers. Now, this is where people start messing up, because what they do is they try to do 2 steps in one. So I'm going to show you the steps that I want you to do and how to break them up to cut down on careless mistakes on your assessment. So this is important for those of you that rush through your assessments, make careless mistakes on your assessments. First thing we do is change them to improper. So that's negative 10/8 divided by 5/4. Do not, in this step, try to change it to multiplication. In other words, the first step needs to be where you change the fractions to improper fractions, okay? Then you're going to copy, change, reciprocal. And the rule is you change any fraction that follows a division bar to its reciprocal. Now, we've separated these two steps. Often people like to do those two steps as one step, and 9 times out of 10, people mess up when they do that. Now I'm going to cross cancel. 5 goes into 5 once, it goes into 10 2 times. 4 goes into 4 once, it goes into 8 2 times. I can cancel the 2 and the 2 on top of each other because that actually equals 1. Now, I have a negative fraction times a positive fraction, which means our answer is negative. And it's ultimately just 1 times 1, which is 1. 5 divided by 1/5 is the same thing as 5 times 5, because you have to copy, change, and take the 1/5 and flip it upside down, which is really just 5 over 1. And 5 times 5 is 25. Now this is kind of a funky problem. 4/7 divided by 3 halves is really how that would be read. So the top part is a fraction, the bottom part is another fraction. And you would just rewrite that, of course, as 4/7 times 2/3. There's no cross canceling that can take place in this problem, so we just multiply straight across. And in our next problem, we're going to only flip the fraction that is after a division bar. And notice that both of these are negative fractions, so be careful because that negative symbol is a little bit hard to read, and that's what my software looks like. So now we're going to cross cancel. So we can cross cancel the 4 and the 8 and the 21 and the 7. And we have a negative times a negative, so our answer will be positive 6. In this example, we need to work with order of operations. And again, be careful and don't try to do everything at once. So this means the opposite of 25/6 divided by 5/1 times negative 2/5. So that's the opposite of 25/6 times 1/5 times negative 2/5. Once you get the problem down to this point, you actually need to multiply what's in parentheses first before you can multiply. Like, we can't just multiply straight across because we have to deal with that opposite symbol. So I can cross cancel within the parentheses, however, the 5 and the 25. So I'm going to get negative 5/6 times negative 2/5. Cross cancel. And I end up with 1/3. Whenever you divide multiple fractions, you always want to flip the fractions that come after the division symbol. Anytime you have a fraction following the division symbol, you flip it. You write the reciprocal of it. So negative 12/21, that's not following a division symbol. So we leave it like it is. We keep it or copy it. Now we're going to flip all the rest of these because all the rest of these fractions are following division symbols. Now we're going to cross cancel anywhere we can cross cancel. So we're going to cross cancel several ways to do this. I'll do the 4 and the 12 and the 7 and the 21. That's interesting. Now I have 3/3. So I can simplify either the 3/3 or the 3 crisscross from the 3. It really doesn't matter. I'll do it that way. On the top, I have a 3, a 1, and a 1. The bottom, I have a 1, a 1, and a 2. So there's nothing else I can simplify. So I end up with 3 times 1 times 1 on the top, which is 3, and 1 times 1 times 1, which is 2 in the denominator. I have an odd number of negatives, which means my answer is going to be negative. Now we're going to deal with fractions that have division and variables. So I'm going to rewrite this as negative 6 over 1 times 3y over 2. I'm going to deal with these like I did in my multiplication problems. I'm going to cross cancel the 2 and the 6. That's all the cross canceling I can do here. Now I'm going to multiply 3 times 3, which is 9, times y is 9y, and just 1 on the bottom. I have a negative times a positive, which is the negative. So this equals negative 9y. In the next problem, we have negative 4x over 5. I'm going to change this to multiplication, times negative 3 over 2x. I can put that negative in the numerator or denominator. It doesn't matter. I'm going to cross cancel. The 2x will go into the 4x 2 times. The x is canceled, so they're gone. The 2 goes into the 4 twice. Nothing else can cross cancel, so I'm going to end up with 6 fifths, and then it's positive because negative times negative is positive, and I'm going to change this to 1 1/10. Now, if there was a variable in this, in 6 fifths, we would not change this to a mixed number. You never change these into mixed numbers if they have variables in them. So if there was an x, you would leave it improper. So that answer should be 1 1/5, not 1 1/10. Moving on, we have 8x divided over 3 times 1 over negative 4 or negative 1 over 4. It doesn't matter. I'm going to cross cancel the 4 and the 8, and that's going to give me 2x over 3, and it's a negative because we have positive times negative. Last problem, 32m over 1 times 7 over 8m. 8 goes into 32 4 times, and m goes into m once, so that's really just 4, and that's going to give me 28, and it's positive.